So when we think about division, the interesting thing about division is if you've already learned how to divide radical expressions, this is the same exact process because I is a square root. So when you take a look at this problem, you may say, well, what's wrong with it? Well, this is really a square root of -1 on the denominator of a fraction, which in mathematics is it's basically a grammar mistake. So we would simply rationalize it by multiplying by itself and on the top and the bottom. Remember, if I multiply something on the top and the bottom and it's the same expression, then it doesn't actually change the problem because these would cancel. And it is, in fact, the identity property. Same thing divided by itself is 1. So on the top, we would just get 3i. But on the bottom, that's where the rationalization happens. We end up getting 2i squared. And as we have seen, I squared is actually equal to -1. So the problem would become 3i over -2. You could write the -2 like that, but most people would simply, because remember this is part of a complex number, so we would actually usually put the negative out there because this would be the bi part, and the a part in this problem would actually be 0. There'd be no real, all imaginary. And in fact, to clean that up even a little bit more, to make it really fit into that pattern of what kind of number this, the I sometimes would be written over here like you would with an X. So keep in mind, if you ever see an I on the bottom of a fraction in the denominator, it has to be down there. But if you ever see one on the side, it's actually part of the numerator. Interesting little fact moving forward with math. Here's another example. Again, I don't really care about the 7 or the 4 or the negative sign. I care about this I right here in terms of trying to rationalize this. And so we would get, on the top, we do have that negative there. Don't forget, so I'll put a little negative right there. On the top, we have 7i. And on the bottom, we have 4i squared. And the reason you can see why I put that negative in there, this will now cancel and become -1. And now this actually cancels with the original negative, leaving you with positive 7/4 I. Again, that numerator variable, especially, it's just good to know what things mean. I'm just going to put it next to it because that's normally how you see it. So what happens if you have more complicated examples like this is you can't multiply simply by an I, because what happens is it will get rid of it here, but then it will generate another one there, and you'll never ever get rid of it. So what you have to do to take care of that is you're going to use something called the conjugate. And the conjugate of a plus bi, right? Conjugate means to give different forms of. So the conjugate of this in mathematics is to simply change the positive to a negative. And if you've seen dividing rational expressions, you'll see what you already know what's going to happen. And if you have an expression that is a minus, then the conjugate is to change the imaginary part to a positive. Now, you may say, how come we don't change the real part? The real part's not the problem. The problem is we want to rationalize and get rid of the imaginary part. So we only change the imaginary part from positive to negative, negative to positive in order to eliminate it. So let's see what happens with this in real life here. So 1 minus 3i is the conjugate. Again, you just change the imaginary part from positive to negative. But you do the same thing on the top because, again, in effect, by doing this, you're really just crossing that out, doing nothing, even after you multiply it. All right, so we'll do the numerator and the denominator separately. I always like to do the denominator first so you can see what's happening. So if I do the denominator, I would get 1. Here I would get -3. Here I would get 3. And there I would get -9i squared. If you wanted to box that up, instead of foiling it, we could do that too. I think the box really shows nicely what is happening. And eventually, when you use the conjugate enough, you begin to realize why, how it works, and you don't even have to, you can just do a lot of it mentally. So 1 times 1 is 1. Here we have 3i. Here we're going to have -3i. And here we're going to have -3 times 3, which is 9, and then I squared. So this term and this term, when they combine, they cancel. And then this will become -1. So this box right here ends up being -9 times -1, or +10. So there's nothing left. There's no imaginary number. So this is just 10. And so you see all that. It got rid of all the imaginary, and that's the main benefit. Here, if you want to FOIL it, you would do that. I'll stay consistent and do this. Again, students ask all the time, well, why do you have the conjugate on the top? It doesn't do anything. Because, in algebra, I have to use the algebraic properties of equality. Whatever I do to the top of the fraction, I must do to the bottom. So that's just staying consistent with the algebraic properties of equality. And yes, nothing will cancel here except for the fact that my I squared is going to cancel out. Like that's going to cancel out right there because I squared is always -1. That has something to do with the conjugate. And so this now becomes -6. All right, so 3 minus 6 is -3. And these two combine here and make -11i. And so that is the answer, but we really want to stay consistent and understand this in terms of its, in terms of the complex number system. This is really supposed to be written as a plus bi, and currently it is not. So if I were to divide this 10, and remember that 10 would have to be divided here and here. It's distributing using division. That would come out being written as -3/10 and then -11/10 with the I on the side over here. Not complicated, but you might see it in that format, and I don't want you to be confused with what's going on. All right, let's just do one more to make sure we understand the concept. I don't care about the numerator because I'm trying to rationalize the denominator. So I change this negative here to a positive. Do the same thing to the top. Again, I like to always do the denominator first because I want to make sure the conjugate worked. Because if the conjugate doesn't work, then it doesn't matter moving forward. You won't have the right answer. So you want to make sure you use the right conjugate before you do the top, because if the bottom didn't work, you got to kind of go back to square one. Don't worry, it almost always works unless you accidentally change both of them, then it would not. So here we get 4, and then here we have -4i, and then 4i, and then -2i times 2i is -4i squared. This is going to change to a negative, changing the entire thing to +4. So I have these canceling. That's what conjugates do. 4 plus 4 is 8. All right, so now let's do the numerator. Now that we checked it out, made sure that the conjugate did what it was supposed to do. Okay. And conjugate's 2 plus 2i. All right, so let's see what we get here. Here we have 6 and 8i and 6i and 8i squared. All right, and so this right here is -1, so this box is actually -8. So to combine like terms, these two make -2, and these two make 14i. And that is not simplified. Unlike the first one, which we just sort of had to look at, it's a complex number, this can actually be reduced. And one of the things I want you to remember about reducing is in order to reduce a division symbol, you need to produce a multiplication problem. And what that means is you need a GCF factor. So if I GCF the 2 out, I'll be left with this expression on the top. GCF just means remove a common factor. Divide this by 2, you get 1. Divide this by 2, you get 7. Put the common factor on the outside. The reason I didn't take the -2 out was because of the fact that it just isn't critically important to do it that way. You'll get the same answer is what I'm trying to say. Down here, I'm going to factor out a 2 as well, so that I can then cancel this, leaving me with my actual answer of -1 plus 7i. Then down here I have 4, and to put it into complex notation, I'd have -1/4 plus 7/4 I. Okay, well, I hope you enjoyed seeing how to evaluate and simplify complex numbers. It's very similar to regular math, other than having to remember that squares of complex numbers need to be changed.